Hi YouTubers. When I retired several years ago, I decided that I wanted to build a model train layout, which is something I'd wanted to do for many years but never had the time or the patience. Now I do. So I set about building a layout, and naturally it got bigger and bigger and bigger and bigger as time went by. And then I decided that I wanted to put a control panel on it that would allow me to see the route a train would take. And I was going to do this using LEDs. And I stumbled on a YouTube video, and I can't think of the person's name right now, but you can find it. It's showing how to use Tortoise switch machines with a combination of LEDs and toggle switches to line your switches from your control panel and show the route that any particular train would take. So I decided that's the way I wanted to do it. Well, naturally I got that done and decided, well, if I've done that, I want to try to put some signals on the layout which would indicate the way a particular switch is thrown, either a line for the main or line for the diverging route. That became a lot more complicated, and I searched YouTube. I'm not sure how thoroughly, but I searched YouTube, and I never could really find a good video that would tie all of those things together, so I decided I would do one myself. So here goes. First of all, some of the things you're going to need. The heart of the whole project will be your Tortoise switch machine. These things are really fantastic. They work first time, every time. I've never had one go bad on me. When I first started, I used Atlas turnouts and switch machines. I still use their turnouts, but I never did really like their switch machines because they're not very prototypical, and frankly, at least for me, they were not particularly reliable. They would work sometimes, sometimes they wouldn't. So I decided to go ahead and take the leap and change to Tortoise switch machines, and I have not been disappointed. These things are great. Next thing you're going to need is you're going to need a toggle switch. And for this particular project, what I found useful was a toggle switch that looks like this. It's a double pole, double throw toggle switch. It's got 6 terminals on the bottom. You'll use all 6 of those. And there's 2 different types of toggle switches that you can get. This particular one is an on, off, on, which means it's on, and then in the center position it's off, and in the upper position it's on. They also make one that is just on, there's no off position. It just goes from the on at the top to the on at the bottom. It really is better to have on versus the on because Tortoise switch machines are a stall machine, and they need to have power to them at all times. If you had it in the off position, the switch may back off slightly from alignment, and you could have a derail. So in addition to the toggle switch, and I'll show you how to wire that in a little bit, and the Tortoise switch machine, you're going to need a signal of some sort. And in this particular case, I use 2 different types of signals. I have either a single head with 2 lights, or a double head, each of them with 2 lights. The single-headed ones are made out of metal, and they're much sturdier. The double-headed ones are made out of plastic. If I could find a double-headed one made out of metal, I would buy it. All of the single-headed signals on my layout are made out of this silver-painted metal. In addition, you're going to need terminal barrier strips for wiring. You really don't need it, but it just makes your wiring a lot simpler. And I'm going to show you this one, which nothing's on it, and this one where I have actually jumped some of the terminals, because you'll really need to do that. And this is going to be for the, bear in mind that on every turnout, if you're signaling it properly, you're going to need 3 signals, which means 3 sets of 3 wires. So this would be 1 wire from 3 different switches, another wire from 3 different switches, and if I had another one on here, it'd just be the 3rd wire from 3 different switches. But you need to connect them so that they're connected electrically, so they'll all do the same thing. And if you don't have this type of a jumper, you can make up your own jumpers. And all you would do with these, unscrew the screws on the bottom and just jump between 2 terminals. That's all you have to do. And then have another one that goes from this terminal over to here. So all 3 of these terminals would be connected to each other. You don't want them connected to the rest of them. You just want the 3 of them connected to each other, and then the next 3 connected to each other, and then the next 3 connected to each other. Now, one of the other issues was, as time went by, and I had my control panel, which I'll show you here in just a moment. I had it wired up with the LEDs. I used bicolor red and green LEDs, and I'll show you in a second how to wire those up. So when I would throw my toggle switch, it would change those signals. So that was a fairly easy wiring job. On the bottom of a Tortoise switch, you've got 8 different terminals. All you needed was the outside 2 terminals in order to do that. You didn't use anything in the middle. Well, then I decided I wanted the signals, so it required going back and doing some more soldering. Well, I don't know about you, but I had a difficult time soldering in the vertical position, because the Tortoise switch machine is mounted to the bottom of your table. You're under a table looking up, pretty difficult to solder. So I discovered these things. They're called edge connectors. They've got the terminals on the bottom. Same 8 terminals that the Tortoise switch machine has. You can take them over to your soldering station, do all the soldering you want, bring them back, and it just slips right on the bottom. Okay? Pretty simple. Easy. Okay, then the last thing, and I'm going to show you a little diagram here, but you need 2 bicolor red and green LEDs. And when you look at an LED, all of them are pretty much the same. They have 2 legs coming out the bottom of them. One leg is longer than the other. I think the long leg's the anode, the short leg's the cathode. It doesn't really make any difference. But what you need to do is take the 2 long legs or the 2 short legs. Makes no difference which ones, they just have to be 2 of the same, and just connect those right there. Just run a wire, solder a wire between, I happen to do it between the 2 long legs, but you can do it between the 2 short legs, doesn't make any difference. But just solder a wire between them. Okay? Pretty easy. And then solder a tail onto the other 2 legs, because you're going to need to run wire someplace else. Now I'm going to show you my control panel so you'll see what I'm talking about. For reference, this is a look at my control panel. Not particularly sophisticated, but it shows me what I need to know. Obviously, the green lights indicate a lined route for your locomotive. If you see a red light, that means the switch is aligned against you and you cannot proceed. I change all of these via a series of toggle switches at the bottom of the control panel. And in addition, what you see on the board is coordinated with a set of signals on the layout. When the toggle switch is thrown, both the LED on the panel, the switch, and the signal all change at the same time. I'll try to illustrate, if you can keep an eye on the upper left-hand corner, you'll see, hopefully. There it goes. The light changed on the control panel, the switch through, and the signal guarding that switch through. I'll do it again. There you have it. Okay, you've seen the control panel, and you can see that I control the LEDs that are on the control panel, the signals that are on the layout, and the Tortoise switch machine, all from a toggle switch. So this is the basic wiring diagram. I'll go over it briefly. I'll show it to you in action. You just have to basically pay attention to this. If you get it wired up right, these things will work every time. You're going to need to have a power supply. I happen to use a 9-volt power supply. You can use a 12-volt power supply. It must be DC. It has to be DC, no AC. If you're running a DCC layout, you can't hook it to track power. You're better off having a separate DC power supply. The more voltage you put here, the faster these Tortoise machines will turn, and the brighter the LEDs would be. I find a 9-volt, or even in some cases a smaller one, would work fine. But I use a 9-volt, and that works great. You're going to have your excuse me. You're going to have your barrier strip just like that. And to that barrier strip, you're going to run 2 leads, just to one side of it. I've got this thing separated. Just pretend there's another block in there of screws. I just left them out for ease, so you can see what you're doing here. But just run the 2 9-volt leads off your power supply, and coming out the other end, you're going to have the same 2 leads. Make sure which is positive and negative. It doesn't make any difference. It's going to go into the rear of your toggle switch. It's going to go into these 2 leads right here, going right into your toggle switch. Now, if you notice, I've got wires crisscrossing here on this toggle switch. In other words, the lower right-hand lead, I've got it joined to the upper left-hand lead, and the lower left-hand lead, I've got it joined to the upper right-hand lead. This is because when you operate the toggle switch one way or the other, you're going to change the polarity. And you have to have it X'd in order to do that. If you had them just from here to here or here to here, it'd just be the same polarity. You have to change the polarity. What that does is throws the Tortoise switch machine the other direction. So you have to do that. Your outbound leads on here, one of the leads will go over to the LEDs, just like that. The other end of that LED will come over, it'll join up to terminal number 1 on your Tortoise switch machine. Now, once again, it can be either way. They're numbered 1 through 8 on the back if you look at them, but it's the 2 outside terminals that will make the LEDs work on your control panel. So one leg of the LEDs goes to one side, the other side, the common, goes back to the other side of your toggle switch. So that's one circuit, one complete circuit. Power goes in, out through the lights, comes to the Tortoise switch machine, out of the Tortoise switch machine, and right back to the other side of the toggle machine. That completes that one circuit. If you were able to take this Tortoise switch machine apart, which I may do later on in this demonstration, you'll see that there's really 3 circuits in here. You've got the main circuit that operates the Tortoise switch machine, which has the LEDs tied into it. There's another internal switch or circuit in here that operates off of pin number 2, 3, and 4, and then a third one that operates off of 5, 6, and 7. For this demonstration, I'm only going to use 2, 3, and 4. I've never used 5, 6, and 7, but I guess you could. But we'll use pin 2, 3, and 4. Those are what's going to operate your signals. If you look at a signal, a single-headed signal, not a double-headed signal for right this minute, but a single-headed signal, you have 3 wires coming out the bottom of that signal. A red one, a green one, and a black one. The black is the common wire. The red one obviously controls the red color in the signal. The green one controls the green color in the signal. So pretend you're going to have 3 switches or 3 signals here, because each turnout has to have 3 signals: the inbound, the outbound, and the diverging route. So you need 3 signals to cover each switch. I've just got 1 here, but it could be 3. Makes no difference. You're going to take the red lead or the green, it makes no difference, and put it in position number 1 on this group of 3. The green lead or the red lead, once again, makes no difference. You're going to put it in position 1 on the second set of 3, and then the common is going to be in position number 1 on the third set of 3. And then the second signal, once again, the red would go here, the green would go here, the common would go here, and on the third set, you're going to have to reverse it, because while the 2 through signals are going to be green, you want the diverging to be red. So if you made both of these 2 red, this one would have to be green, and if these 2 are green, this one has to be red. The blacks are all the same, makes no difference. You just have to put them in there. So you have to determine if the signals are lined up the proper way. So when the switch is thrown to allow trains in both directions to go through on the main, you want them to be green. So it'd be green, green. For the first, it'd be green, green, and red, and this would be red, red, and green. So they just have to be opposite. You have to figure it out yourself. If you're using a 2-headed one, pretty much the same, except there's just more wires. You got 5 wires coming out the bottom instead of 3, because you got 2 reds and 2 greens. You have to just figure out which one of these wires controls a red one on this one and a green one on that one, and just twist those 2 together. And then the opposite would be controlling the opposite color on each of those 2. You have to twist those together, and then once again, if it's when the signal is thrown or the switch is thrown in the direction you want to go, and you know what color you want, you just either put it under here or under here, and see which 2 colors light up. And if it lights up the way you want it, then leave it there. If it doesn't, just reverse it. Now, to get power to this, once again, it's pretty simple. The 3 terminals on the Tortoise machine, once again, pretend you have red, green, and common. Now, it could be green, red, and common. Makes no difference. Just the second terminal goes over to this group of 3, so that'll activate it when the switch throws. It'll send power to this group. The third terminal goes to this group, and once again, makes no difference if it's red or green. You'll have to just determine which color it is, so that when the switch is thrown the other way, it activates, it sends power to this group of 3. The common right here has to go over to your power pickup, your inbound 9-volt DC. Doesn't make any difference which one of these 2 you put it on, just the other one, the one that you don't put it on, which in this case is going to be this one, you have to jump it over to your common. Now, if you put the power here, then this is the one you move over to your common. Makes no difference, once again. Well, technically it does make a difference, which I'll tell you in just a minute. But you just have to run the third, which is really the 4th terminal, has to go to either side of your power, and the other side of your power goes over to your common. That's your whole circuit. Now, LEDs, not the bicolored ones, but the single colored ones, they're polarity sensitive. So you hook all this stuff up the right way, and you don't get any action out of here. You just got these 2 reversed. So you would just put this one over here, and this one would then come over here. All you have to do is just reverse the polarity. You can't run it through the toggle switch. You have to run it right through here. Just reverse the polarity. Now, I'm going to show you this whole thing in action. I have a little testing jig that I made up, and I did this because if I buy any signals or LEDs, any of that stuff, I like to test them and make sure they work before I install them, because the worst thing you do is install it and find out it doesn't work. So once again, here's my barrier strip, here's my signal, here's my switch, here's my toggle switch. And behind the toggle switch, pretend this is what's on my control panel. I've got the green and the red. All you do, simply, boom, throw the switch, this signal will turn colors, this signal turn colors, and the switch through. So with this signal, you're going on the diverging route, which the switch is thrown that way. And over here, the diverging route shows green, because you need that on your board so you know which way the train's going to go. So you've got a green on the diverging route, you've got a red on your switch signal, which indicates the diverging route, whereas the green indicates the main. And I'll switch it back. There's green. So now your line for the main, the switch is line for the main, and you've got a green on the main. This is exactly the way it'll operate. There's my Tortoise switch machine underneath. Pretty simple, all in all. And if you do this right, it'll work every time. Now, as far as the Tortoise switch machines, I'll talk briefly about those. There's lots of videos on YouTube on how to install Tortoise switch machines. Some of them are better than others, but I'll tell you, it's an age-related thing. I think the younger you are and the better your eyes are, the easier these things are to install. The older you get, the harder it is to install them, because you're doing everything over your head, underneath the table, sitting on the floor. And one of the things that you're asked to do is you're asked to take this little wire right here, this which actuates the switch. You can see as I move that, it just shifts that over, so it throws your switch. There's a little hole between the tracks on the switch, and you have to put this rod up through it. The easiest way to do it is to center it, first of all. Now this is after you've determined where you want this machine, where you want your switch, and you've drilled a hole down through your layout. There's directions in each of the Tortoise switch machines. It says to drill a 1/4 inch hole. I drill a 5/16 inch hole. You can drill a bigger one. Doesn't make any difference. You don't want to drill it too big, but as long as it fits between the tracks, you're okay. And you're sitting here trying to fish this thing up from the bottom of your layout and put this in that little tiny hole, which is just slightly bigger than this. I couldn't do it. It drove me crazy. Finally, I said, you know, got to be a better way. All I do is you just take a screwdriver, unscrew this screw, you pull this piece of metal out of there, and feed it down from the top, and put a little clip on it on the end to keep it from falling through the hole, and then get back underneath the table, grab it in your fingers, and then just assemble it back to the switch machine. So that makes it pretty simple. Now, as far as locating this thing, because once again, you got 4 places on the top here where you have to have screws. You really only need 2, 3 at the most. You don't need all 4 of them. They tell you 4. You don't need it. This thing's not going anywhere if you get 2 of them tightened down pretty good. But you have to locate it, and it's got to be centered, and it's got to be located perfectly. Otherwise, it won't throw the switch. So they give you a little template in each of the kits, and it's made out of paper. I had a heck of a time with that. Once again, over my head, underneath the table, trying to get that thing to stay in place so I could locate these 4 little holes. And you'd have it centered over the hole you drilled. Once again, it was a pain in the neck. So I just made myself a template. I just made it out of some fiberboard. No big deal. All I did was take the template that they give you, put it on a piece of this fiberboard, mark it, cut it out, and I drilled a hole in it. I put a 5/16 inch dowel rod, which is the same size as the holes. I just drew a straight line there and a straight line there, because you do want these lined up. If the switch has to be this way, you want it lined up that way. You wouldn't want it lined up that way. If your direction to travel is this way, you don't want the switch going this way. So you have to have it lined up, so I just do that. Simply stick this thing in the hole. Actually, you do it this way. You put the long end through there, and you're doing it from underneath. And then you just take an awl and you poke it through the 4 holes. It'll locate where your holes are for your screws. It's simple. Once again, it takes no time at all. And the last thing I would say before I wrap this up, these Tortoise switch machines, I'm not going to take this one apart, but there's 5 screws in here that hold this on. And now, if they're under warranty, don't do this, because this will absolutely void your warranty. But if they're not under warranty and if they jam, because sometimes if you manually shove this over like that, you'll get it out of a line and it'll freeze up and it won't work. Okay? But I'm telling you, just take those 5 screws out of there, lift this half off, the screw side, lift it off, and you'll see there's only about 5 moving parts in there. You got 3 or 4 maybe it's 4 or 5 little gears, and you've got an arm, an actuating arm that rubs up against some electrical contacts. You take them out, grease them up, whatever you want to do, put them back in there. If there's any teeth missing off of any of the gears, then you may have a problem. But if there's no teeth, you just line them back up, put them in there. It's simple. These things will last you forever. I bought every one of them I got on my layout. I bought used. I haven't bought a new one yet. The used ones work fine. There's no problem because there's nothing in them to break. I'm telling you. Anyway, I hope that this will help anybody. I mean, I had a heck of a time, and once I've got it figured out, I decided I'll try to put something together. This is my first shot at a how-to. Hope you find it interesting. Leave any comments. I'll try to get back to you. Thank you for your interest.